Okay, 4.7 is proving polynomial identities. So a polynomial identity is a polynomial equation that is true for any value that is substituted in for that variable. Okay, so all that means is once it's simplified, if we plugged in the correct things, it would all be true. The left side would equal the right side, which is why they have equal signs. So you start off with something that doesn't look the same. So like this one says x plus y all squared equals x squared plus 2xy plus y squared. So this is the most basic one we could ever have in the world, okay? This is where you have to either rewrite, expand, it's the same thing, okay? And show your work and show how you can rewrite whichever side to show that one side equals the other. Well, this is broken down as much as it can. I can't rewrite this because you can't combine like terms and you can't do anything to the side. So you look at this side and go, x plus y all squared. Can I rewrite this? Well, yeah, that is really something times itself. So I rewrote it and I wrote rewrite over here. Then I go, what do I do to this when I have two binomials together? Well, I'm going to FOIL, and that's what this next step is. So in line with it, I wrote FOIL, and that's what I did to make this step. And then the last one says CLT, that's combining like terms. So I just abbreviated it. So all I did was combine those middle terms, and I have this. Then I look and go, that is the same as my original thing up here. So I brought it back down, and I wrote, hey, that's true. And this is based on proofs. And when we write proofs, especially like in college later on, they put a little box at the end and fill it in. That means it's true, it's completed. So that's what you do to prove it. So all you have to do is do math, whether it's usually a lot of foiling or multiplication and combining like terms and rewriting stuff to see and seeing what you have, because sometimes you don't have to go all the way. So if you look at the second one right here, okay, this is the big problem. So you have something squared times 4 terms and then 3 terms times something cubed. Okay, so since these have something squared and something cubed, you're going to have to break down both of them, because look, this 4 term and 3 term, they have nothing in common. So on this side, all I did first was break down something times itself, and then I did it. So I expanded it, and then I actually FOILed it, and I stopped. Once I FOILed it, I stopped, because then I would come over here and I would do the same thing. So I rewrote this as 3 of them, right? And then I only did 1 of them, because you can only FOIL 2 of them at a time. So I FOILed 1 of them, and then I stopped. And like I said, expand and then stop and then FOIL. So when you look at this, you go, do they have anything in common? Look, x squared plus 2x plus 1, x squared plus 2x plus 1. So since they already have this much in common, you leave that part alone. You go, okay, that has 4 terms. So that means I want this to be that. These have to be the same. Well, this is broken down, so that means I want this to make that. So I go, how do I make this times that into that? We multiply them, or you're really foiling again, right? So you take this and you're big distributing. Remember, this is going to take up some space. So knowing how to FOIL and distribute is going to save you a lot of time. So you multiply these and combine your like terms, and I get this guy right there. And then, since you already had these to be the same, I only have to look at these. Are these now exactly the same? I did FOIL and combine like terms in 2 steps. So it might take you 2 steps. And go, once everything is exactly the same, since this is multiplication, the order wouldn't matter, but okay. Then I'd write true and I put my little box that's filled in at the end. And that's it. Okay, next one. This guy, x squared plus y squared all squared equals x squared minus y squared plus 2xy squared. Remember, this is binomial, so you're just going to distribute that. So we got a lot of stuff to break down. So I'm first going to expand. Expanded that, and I distributed that, because that's what expanding that is, because you can't write this twice, because it's a monomial. With monomials, you distribute in and don't forget to put on the number. So this one over here, you would FOIL it, okay? This one over here, you would FOIL it. And then this I just simplified. Then next step, I combine like terms only on this side because this had nothing to combine like terms. So this combine like terms, and I underline the things I combine like terms. And then they're the same. Because look, this was almost the same. It said this plus 2x squared y squared, this said minus 2x squared y squared. But these had extra terms. So you just pay attention each step and go, how are these similar? How are they different? Okay, and then the last one I will do in class is this one. X plus 1, x minus 1, x minus 2 squared equals x squared minus x plus 2, and then x minus 2. This has an x minus 2, this has an x minus 2, but because this is squared and that's not, we're going to at least need to break this down and see what we can do with it. So break this down. Now you see how these are the same? So leave these alone. So see if what's left over here, if it can make that. So multiply these, FOIL these. Look. It did. So you only actually had to do 2 things, like break it down and multiply once to make that step. So it's always good to pay attention to what you actually have because it'll save you a lot of time.